But before you can talk about profiling optimization, you have to kind of understand performance. And what do you mean by performance? And unfortunately, it's a very complicated subject. For web applications, performance is often, the most important performance is perceived importance. It doesn't mean it has to be fast, it means it has to feel fast. It has to feel and look fast, but it doesn't have to be fast. And that's a different thing, because there are ways you can make it feel fast without it being fast. Such as like splitting. If you have a very large page, you can split it up into multiple AJAX requests and have the page load incrementally in pieces. And that will make a page feel fast, but it will actually be slower. And so it's all about the perception of speed, and it's going to vary based on your users' needs and your customers' needs as to what fast is. Also, performance is often related to like lower level pieces inside of a computer, such as network I/O, disk I/O, memory, and wall time. Those are generally how you kind of measure performance. And we'll be looking at different ways of improving each of those. So there's a real question of why bother? You have an application, it works. Why would you make it go fast? Like, why waste the time? Other than like developer pride, you have to have a reason, right? So some reasons that you can take to your stakeholders, to your clients, to your business owners, are you can talk about higher conversion rates. So there's been a couple studies that prove that the faster your web application feels, or the faster it actually is, the more money you'll make. In 2009, Microsoft found that Bing searches that were 2 seconds slower resulted in negative 4.3 revenue per user. And the opposite of that is when Mozilla shaved 2.2 seconds off their landing page, Firefox downloads increased by 15.4%. I don't have sources for those because I forgot to get them, but you can find them. Amazon has also noticed that every time their page gets slower, they lose money up to a point. Same with Google. So there is research that shows the faster your application is, the fewer people will get frustrated by it, and the more probable they are to pay you. So some other reasons you want your application to be fast is people have slow mobile connections. I don't have a phone, but I've heard that it gets really gross when you get onto like a G3. I can't remember the name of it, but the non-highest end connection, you get onto like a roaming or a non-fast connection, and you get a really slow one. Also, if you're on conference Wi-Fi, a fast site is good because conference Wi-Fi is often bad, or airport Wi-Fi, or cafe Wi-Fi, or any Wi-Fi that's not at your house or your office. Keeping your site fast is often good for these use cases. Also, there are many parts of the country, like many parts of the world, that don't have fiber optic. We're all pretty lucky because we all have fiber optics, but there are many parts of the world that don't. So faster sites are easier ways to get engaged with those people. You can also conserve capacity. We had a fun problem at work where we released a new feature and it doubled our API traffic, which means we exhausted all of our capacity for next year. So that means we would have had to buy 4 extra servers. So by fixing the performance issues there, we were able to not buy 4 servers. That's one of the, from what I've heard, that's one of the initial motivations for HHVM as well. Facebook was able to make PHP 4 times faster, so then they need 4 times fewer servers, and they can provide Facebook at a much faster rate. So the rest of this talk is going to be mostly about rules, but they're pirate rules, so they're more like guidelines. And these are all kind of guidelines that I found from my work. And profiling, I usually mean measuring through samples. So you take a snapshot of how your application works, and then you do some science. You do some work, and then you do some more science, you take some more snapshots, and you compare them. If you cannot snapshot or measure with the thing you're trying to improve, you have already lost and you will never improve it. So the first thing to be able to do to improve anything is to measure it. If you cannot measure it, you cannot improve it, and you should stop trying to improve it. First you have to measure, and then you have to do some work, and then you measure, and then you apply science, which is basically subtraction or division. That sounds funny, but that's what I call science. So the next thing you're going to want to do is go after the big fish first. If you're looking at performing improving the performance of a piece of your application, you're going to want to start off with the really important pages for your business or the really important parts of your workflow. Sign-up pages, checkout pages, all the things that turn into reasonable things for the business. So if you make money by selling subscriptions, that subscription page and the page where people pay you should be fast because those are important. If you have an important dashboard page that your customers use every day, all day, make it fast because that will keep them happy, and then hopefully happy customers keep paying you because angry customers leave. So find your key conversion points. If you don't know what they are, you've just learned something. You should find out what your key conversion points are. What are your key metrics? How do you monitor them? How do you improve them? How do you track them? The reason you want to start with the biggest areas is because you can have the biggest impact. You can often get into the very horrible world of micro-optimizations where you're saving 0.5% on 1 millisecond. You're not going to have measurable gains there. I would also say start with the cheapest things to fix. You can spend a lot of time improving code, but if you are doing 300 HTTP requests on your page, you have lost because you are fixing something that is very small when you could be fixing something very big. So the way I look at things is you start at the top and you go to the bottom. If you haven't done things at the top, you should not do things at the bottom. So you start off, if you have uncompressed CSS and uncompressed JavaScript on your page, that's easy wins, right? No problem. If you have uncompressed images, like you're getting the images from the designer and you're just dumping them into the website, that's an easy win. There's literally megabytes of extra data hiding in your application's assets in hidden metadata that you don't need to put on the wire to your customers or your clients. Reducing the number of HTTP requests. HTTP is not exactly the cheapest protocol in the world. If you can do fewer requests, your site will be much faster because you have to open fewer connections, so it'll be faster. Database queries, caching, and code optimization all happen after the end. There's no point in caching queries if you can just make them faster, right? Caching adds complexity and trouble and overhead, so if you have a slow query, just make it faster. Then you won't have to cache. So junk up front. This is a picture of the New Relic graph from FreshBooks, the company I work for, a couple years ago. So we can see at the top, the yellow is DOM processing, which basically means downloading garbage off the internet and running JavaScript. The brown part is network. That's hard. The bottom part is the PHP, the purple part. So if we were going to try and optimize something, we have 2 seconds not in PHP. We have, where the heck's my cursor? There it is. We have 2 seconds not in PHP, so the top half. We have 500 milliseconds in PHP on the bottom. And if we were going to try and save 10%, so 10% in performance optimization is that's a good savings, right? If you can get more than, anything less than 10% is not so good. 10 to 80% is amazing. So if you were going to save 10% on your 200 milliseconds, the bottom piece, if you were going to save 10% on the top piece, you would save 200 milliseconds off your page load time. If you're going to save 10% off the bottom piece, you'd only get 50 milliseconds. So you can get a 4 times improvement by just picking the part that is the biggest wedge and make the big wedges smaller until all the wedges are really small, and then you can kind of get down to attrition. Yeah, so this graph was from 2013, because I gave this talk a couple years ago. In 2011, our invoice edit page was 68 requests and 125 kilobytes. Today, it's 24 requests and 18 kilobytes when cached. So we got it down pretty well, and we didn't do any code optimization. This was all front end. So measuring this type of stuff, you can use your browser tools. Chrome and Firefox have really good browser tools for looking at what is going on, what kind of requests your browser is making, and whether or not they're cached. Yeah, these timelines are really useful. They'll also tell you, like you'll see 304 okay. That's because I'm force refreshing the page. If you're not force refreshing the page, you'll see these come in as 200 from cache, which means the browser didn't even make a request. Obviously, that's the best case scenario you can have because no HTTP means it's fast. And they're just reading off the local disk. 304 is pretty good if you have assets you can't cache forever. So So things you want to look at: the number of requests, the number of hosts, the image count and the image size, the script count and the script size, and start attacking the biggest piece that you have and see if you can make it smaller. Some pages will have multi-megabytes, like many megabytes of images, and you can't do anything about that, right? Like if you're Flickr and your page has 10 megabytes of images, that sucks. You have 10 megabytes of images, that's what you do. Like, however, if you're like a blog and you have 10 megabytes of images to make borders and background colors, you probably have a problem. I find there's not any real hard and fast rules. It's a lot of looking at what you have and seeing if it makes sense for what you're doing. If you have 3 megabytes of JavaScript and you have if you have an AngularJS or an Ember.js application, that might be reasonable. If you have 3 megabytes of JavaScript and you have a blog, problem, right? Like, it's all about looking at those kinds of things. The number of hosts is interesting. HTTP and most browsers have a limit of the number of concurrent requests they'll do to any single host. It's usually between 4 and 8. Some browsers will cheat and go higher, but there is a limit for the number of concurrent requests. So an easy way to get some faster pages is by adding a second or a third host for, say, your static assets. And then what you can do is you can download 16 things at the same time, because the browser will just saturate the network connection and download 4 to this host and then 4 to assets.yourcompany.com. So you get 8 things at the same time. So you'll get the timeline, instead of it being like a snake, it'll flatten up a little bit. And when you're looking at that network graph, this network graph, the thing you're looking for, there's actually farther on the right, there's a green line and a red line. And the green line is DOM content loaded, which is when your jQuery on ready fires. And then the second line is when window load, which means all of your document.ready scripts have finished, or whatever you're using. So good ways to fix this: smush it. There's a good Ruby program called Smusher, where you give it a directory of files and it'll just sit there and do HTTP requests to smush it and compress all the files. I did this on FreshBooks code, and I got like 75% savings on my images. They all look the same, they're just 75% smaller. Pretty cheap. It took 10 minutes of work. I committed a huge diff and the site was faster. Seemed good to me. There's also Uglify for JavaScript. You can get like 60% savings on some JavaScript files. It'll strip out all the comments, strip out all the white space, rewrite all your code, rename all the variables. It's a fantastic tool. There's also JSMin, which isn't as good as Uglify. As far as I know, Uglify is kind of the gold standard for JavaScript compressors at this time. CSS is not nearly as squishy as JavaScript, but CSS-min does a pretty good job. It'll strip all the white space, strip all the semicolons at the last declaration. It'll take those out because you can get some savings there. If you type 0 pics, it'll just change it to 0. It'll take hex codes that have 6 characters that are the same and turn them into 3. So it's all these little like bite shaving things. And a good way to automate this is with Thing, with make. I like make. Some people don't like make, but I love make files. Thing, you can use rake, grunt, gulp, broccoli, and any of the vegetables that come from the JavaScript family. They're all pretty good. Just pick one. It's all up to you. You can use shell scripts. I like make files because it makes me feel like I'm in the 70s. I wasn't around, so I missed it the first time, so I get to do it now. Image sprites are another good alternative. If you have lots of little icons, people are switching more to icon fonts, but if you need multicolor icons, you can't use a font. So you can either alter your design so you can get away with single color fonts and use icon fonts, or you can use image sprites, which is a technique from the 90s. Where you kind of take all your icons and put them on one big image, and then you just slide the image around and make little squares, little windows into the big picture, and you slide it around so you only have to download one big image instead of having to download like 60 or 70 little images. That was something we did early on at FreshBooks as well. We were downloading, I think it was like 65 icons on one page. It was ridiculous. So now it's one. Yeah. So obviously the easiest way to make your site faster is to do no work. The fastest application is the one that doesn't run, right? The hello world is fast because it doesn't do anything. If there are ways that you can not do any work or defer work or maybe do work later or process it in the background, those are all good ways to get significant savings. If you have an action at the end of it, you have to send off 50 emails, maybe you should consider using a queue or putting it into, a queue would be probably the best way. Put it into a queue, process it later. There's no reason that your user has to wait for you to send emails, right? those are often good ways to save things. Other ones, if you have a lot of optional modal UIs, at FreshBooks, they love, our UI designers love modal windows. So everything is in a modal window. And if we load all that HTML up front, it's a lot of work. So what we do is we just load the modal windows as people click on them. There's another really fun technique I heard from a company in the US. They have a button that opens up their little application, and they have a very minimal script that inserts their button, and then they use mouse move detection to see if you're coming close to the button. And then as you get within 400 pixels or 200 pixels of the button, then they load their application down because they want it to be there when you're going to click on it. And so they wait for you to get close to it, and then they load it. So if you never go near their button, it never loads, so the page stays fast. So there's those kinds of, like, they sound pretty hacky, but they're pretty neat. Like, you can, if you know that one step precedes the other, you can wait for the first step to do the second step. So those kinds of, there's little tricks like that. Other fun things to do, or like useful things, is configuring your web server properly. A properly configured web server can save you a ton of speed, or give you a ton of speed. Before I do any code optimizations, look at the web server. There's a lot of easy stuff. So things you want to do is look at the headers and the response headers for your stuff. If you see at the bottom, you have that no store. This is a bad one. You have no store, no cache, must revalidate, post check, 0. That means you want the browser not to cache this request. If you see that on your CSS and your JavaScript, you should fix that, because that means on every page load, the browser is being like, what's the CSS file? Okay, well, it didn't change, but here you go. So what you want to do is get it to the point where all of your static assets are static, and they go to the browser once on the first load, and then they stay there until you update the file. Yeah, so what I usually do is I'll just reload the page a couple times, or just click around and see what doesn't come from cache, and see if there's a reason for it not to come from cache. Does it contain dynamic data? If not, why aren't you just caching it in the browser until it changes? We had a really fun thing at this at FreshBooks. We let people customize the color of their account, and they can pick red. And then for the longest time, it was not cached because we had to generate it from the server. Because it could change, like we didn't know if it would change. So every time the person would load a page, you'd be like, what color is the account? Oh, it's red. Okay. Well, we need to make this red. So we'd have to go to the server, go to the database, get their colors, generate a little CSS snippet, and show it to them. So eventually that got really taxing, and that became one of our performance problems. What we ended up doing is computing a hash of their color and the date that they modified their account, or modified the table that contained that color, and then we would know. We could just generate the hash, cache it for forever, and if they change the color, then we would change the URL, and then they would get a new file. So there's types of things like that, where if you know what the content is, you can generate a caching header called an e-tag, or you can just change the URL based on the hash, and then you can permanently forever cache things, even on dynamic content. Other good things to do in your web server is gzip all the things. If you don't have gzip on, turn it on. You get 60% benefit for free. You don't have to do anything. You just, in Apache, it's add output filter deflate, and you give it the list of content types, and you win. You restart Apache, you're done. It's a huge benefit for basically no effort. And nothing will break. It'll just work. So that's the first thing to do. Like when you're clicking around, make sure gzip is on. Far future cache headers, you can do this at the web server level too. You can do things where you can add headers based on the content type. Both Apache and Nginx and IIS, and basically every web server supports this. Excuse me. You can say for CSS files, cache for 99 years. For JavaScript files, cache for 99 years. And then when you do a deploy, you change the URLs of the asset files, and you automatically break the cache. So you don't want to get into a place where you're doing cache invalidation, because it's hard. So just change the URLs, and that's how you do cache invalidation. Other things that you can do on web servers is, if you have the capital or the resources for it, or if it makes sense, invest in a CDN. Companies like Cloudflare and Limelight can hugely improve the performance of your application, because they'll put data centers close to, like the edge nodes of the CDN will be closer to your users, which means they don't have nearly as much network latency to get your stuff. SQL molasses. Have you ever had a database, a slow query in your database? No? Just a couple people? Just Kim? Kim's the only one who's ever had SQL problems. I've had a lot of SQL. At work, we are consistently bound by database performance. That's our big problem is database. So many backend performances come from SQL. MySQL has a pretty terrible query planner. Up until 5.6, it was horrifically bad, in my opinion. If you included queries that had subqueries, you couldn't actually run explain on them without evaluating the subquery. Jose's told me that the query planner is not terrible in 5.6. MySQL also has other fun things where it will only use one index per join. So if you have multiple indexes, it'll only use one. Subqueries and derived table joins are now banned at FreshBooks. You're not allowed to do a derived table join because we have never had one ever successfully survive going into production. We're also not allowed to use views because every time we've done that, we've taken the app down. There's a bunch of things if you just avoid in MySQL, you'll have a much better life. So a derived table join is when you do a from and then you do a subquery in the from, or you do a join onto a select query if you've never hit a derived table join. When you do the explain, it'll say derived table join, and then you'll get like a huge number of rows on the other side. So good things to monitor this are the slow query logs. An interesting thing to do with slow query logs is most people set a threshold. What we did is we set the threshold to 0, which logs everything. This was interesting because Percona makes a set of tools that allow you to generate histograms of what queries are running. So it turned out that we had a few slow queries, which we knew about, but we also had a query that executed 3 times on every request. That was interesting. And it was always getting the same answer because the data didn't change. The query was fast, but it accounted for 15% of our database query loads. So we got it down to 1, and then it was only 5%. So we got 10% of our database capacity back by just looking and being like, why does that run 3 times more than every other query we do? And it's because we were doing too many. Turned out what it was getting the session. So we just took the sessions and threw them in Redis, and then we got 10% of MySQL back. So those kinds of things that you can find out before you poke around at code. So Percona makes really great tools for MySQL. I've not used the MariaDB ones, but I know the Percona tools are great. Some other optimization techniques for MySQL is disable query caching, disable basically every cache. This is true for everything below 5.6. I don't know about 5.6 because I've never used it. But for 5.5 and below, turn off every cache. Cache eviction is a linear search. We had the table cache at 3,000. We have more than 3,000 tables because of the way our database is sharded. So then we filled up the cache, and then we had to do cache evictions, and bad things happened. So from our experience, turn every cache off. It sounds like this is better in 5.6, so you're going to have to test. Also, indexes are really important. A lot of people will assume that their database is slow because they notice it's slow, but they fail the part where they fail to run explain on their queries and find out that it's doing table scans. That's an important thing. So this is a tool called PT Visual Explain. If you ever looked at the results of explain query, they're somewhat cryptic, and you kind of have to read the MySQL docs really carefully to understand what it's saying. This tool breaks it down into a nice tree, and you can look for interesting things. There's nothing really scary on this one because it's got bookmark lookups and filter with where. It's using keys on everywhere, but sometimes you'll see table scan multiple times. You need an index then because you're using a table scan. Yeah, if you look at the MySQL docs and look at the order of goodness for explain results, it's like const, bookmark lookup, index lookup, and then table scan. Table scan's really bad. If you see table scan, bad. You have to figure out a way to fix that. Usually it's by adding indexes. So you want to index the columns you use to search on. Also, the column order matters in an index. So if you have an index that includes 2 columns and you only search on the second column of the index, MySQL will fail to find that index. So make sure if you search on one or the other column, but sometimes both, make sure you have both indexes. Because you'll need to index the column in both directions because I think the indexes are stored in a B tree. Maybe, yeah, they're stored in a B tree and it can't find the second condition if the first one doesn't exist. So So yeah, index both ways. We do that quite a bit. It works. Yeah. So caching is often cited as the panacea to all performance problems. Just put a cache in front of it. This is often useful for heavy read loads. If you have a heavy write load, caching will just make your site slower. Another fun thing is if you have caching and you never read the cache, that's also bad. I was in a bus with Rasmus Lerdoff, and he told me this really great story of the people at Yahoo, and he did a consulting with them, and they said it was one of the teams at Yahoo. I don't know which one. It doesn't really matter. The story's good without it. The story was that they had a consulting at the beginning, and Rasmus was like, yeah, you got to cache this set of data. So they did. They wrote the cache, and they're like, the site's still slow. And then Rasmus sat down and looked through the code. He's like, you never read from the cache. and they're like, what? He's like, well, you need to read from the cache. They're like, we need to read it. So if you put caching in and it's not working, the site's not getting better, make sure you're reading it. There's really basic stuff where you're like, oh, I wrote to the cache, but I didn't read it. Now you just made it slower. Also, if you have strange access patterns, so we have lots of little tiny customers. And if we cache, let's say we cache an invoice, that customer might not come back and read it ever. They might read it once. So if we cache it, that's great. We've just given allocated memory to this object, but they might read it once. So we just don't cache anything because the read access patterns are too wide and not focused enough that we would have like a 2% cache hit rate. So if you're going to cache things, make sure the cache hit rate is going to be pretty high. So caching can be expensive to roll out if you need new infrastructure. Oftentimes people will try caching into a file, and you should be very careful with that because unless you have SSDs, it will be slower than whatever you're probably reading from, unless it's a remote service. If you're caching database results into a file, profile it, make sure it's actually faster. It might not actually be faster. Cache expiration can be really hard. What I usually do is try to avoid cache expiration, just set the cache TTL for a really long time and just change the keys because then you don't have to deal with like thundering herds when all your cache keys expire at the same time. So if you are going to go caching, make sure you cache results that don't change often and cache results where the hit ratio is going to be good. Make sure you use monitoring to figure out what your busiest pages are. Start with the caching there. See if it makes a noticeable improvement for you. And expand once you've learned. So if you have a really busy page, like a home page for a news site, right? If it doesn't change every hour, maybe cache for an hour and see if it cuts down your load. And then you can go from there. So where to cache? Hopefully not on a disk. Ideally, you want to put it in Memcache or Redis. Failing that, APC and WinCache are good. APC and WinCache are per server. So if you are running multiple web servers, you will end up caching everything multiple times. Memcache and Redis are nice because you can have a centralized cache that everything can share. Files, often not faster. So watch your cache miss rate. If you're using Memcache or APC, you can get statistics and WinCache and Redis. You can check what your miss rate is. So that's when someone requests a cache key, they want to read a cache key, and it's not there. If your miss rate is significantly high, that means you're spending time talking to the cache, missing, going back to the primary data source, doing the query, getting the results, probably putting them back in the cache so that you can miss it next time. So at that point, your caching is now a liability. So yeah, tune your expirations, tune what you cache so that you're getting good usage. So optimize your code last most of the time. Unless your data shows otherwise, probably don't optimize code. There will be cases when you're clearly CPU bound and fixing code will give you the most gain. Generally, all the other stuff that precedes code optimization will get you more bang for your buck. So we're going to probably be working primarily in two languages, I'm guessing, JavaScript and PHP. JavaScript is characterized by like janky pages, the browser beach balls, you get that script timeout alert. Those things are annoying. JavaScript is tricky in that different browsers have different performance characteristics. So the way Firefox and IE and Chrome behave is all very different. So you're going to have to try all of them. PHP is often characterized by a slow to load page. You can check this with Siege or New Relic or whatever monitoring tool you're using. So JavaScript, you can use the Chrome dev tools are fantastic. The Firefox dev tools have really caught up recently, and I would also recommend looking at them. CPU profiles are fantastic in both tools, and you can also do heap comparisons in Chrome, so you can look for memory leaks. The CPU profiler in Chrome, you go into the Chrome dev tools and then go to profiles, collect JavaScript CPU profile, and then hit start, and do the thing that you think is going slow, and then click stop, and it'll spit out a graph that looks like this. This is again a real problem we had at FreshBooks. So you can see way down on the bottom, we have just more than half a second to do one thing, and this is after a click. So you would click, and then you would wait half a second, and then something would show up. 684 milliseconds later, which is a really long time. So down at the bottom, we see 418 milliseconds rendering a menu. And what happened here, this is a rare thing, but jQuery was the slowest part. We were putting HTML tags into jQuery, and it was parsing them and turning them into DOM nodes, and that was slow, because we were doing it 25,000 times. Wasn't jQuery's fault, it was partially ours. We were doing too many. So we did some work and got it down to this, which is 27 milliseconds. Turns out DOM create element is super fast. So there's just weird cases where a library would normally be quite reasonable, like parsing HTML is usually generally pretty reasonable with jQuery until you do it 25,000 times. And you won't find that until you do some profiling, figure out where the problem actually is. So yeah, we thought it was some sort of loop in our code, but it turns out it was a problem deep in the bowels of jQuery autocomplete menu. Our code looked sane, something in the library went funny. Yeah. Yeah, the Chrome DevTools also have a really neat tool called a flame graph. So it allows you to take a CPU profile and turn it into what they call a flame graph. And so there's two axes here. There's the x-axis, which is time, and the y-axis, which is stack depth. And so what you want is see at the left-hand side, there's lots of tall, narrow towers. That means that a function executed and it went really deep, but it didn't take much time. On the right, we see more functions that are running for a longer period of time, and those are generally the problematic ones. Like those, if your blocks in your flame graph get too wide, you have a big fire, and if it's both wide and tall, you probably have some fire in your code. And those are often good ways to find areas where the code isn't doing what you think it should. You might have a loop that's going out of the way, or an action that gets called 20 times calls 900 functions, and then gets slow. Yeah, so that's an interesting tool. PHP, we have a couple tools. Specifically for Cake, there's Debug Kit, which gives you a really high-level look at your application. So I wrote that, and it's pretty useful. Yeah, it's also handy for development because it lets you look at your view variables, your session, your logs, your SQL query. It kind of gives you like a really high-level snapshot into your application. If you're not using it, I would recommend it. It's already been ported to 3.0. I did it this week. So yeah, it's ready to go. Another really good tool is XHprof. This is a tool that was originally built by Facebook when they were running PHP. It's a PECL extension. It doesn't work great with PHP 5.5. So there's another fork of it called uProfiler to be used for 5.5. It lets you capture metrics at the function level. So you can capture how long a function takes, how many times it was called, how many milliseconds it spent in CPU, how much wall time it spent, the memory that that was allocated during that function, and the peak memory that function hit. It's also, XHprof is really nice because you can use it to profile a subsample of production. So you can do something like if you have multiple web servers, you can profile 0.5% of your traffic. And then you'll eventually aggregate enough of a corpus of data where you can do meaningful stuff with it. Don't ever run Xdebug in production. Just don't. Xdebug will slow your code by a factor of 3 to a factor of 5. XHprof is about a 5 to 10% tax. So if you can take 5 to 10% tax on 0.5 of your request to figure out what's going on, it can be worth it. So XHGUI is a tool that I worked on with Paul Reinheimer to make sense of data from XHprof. There's another tool that Facebook produced, but the code is kind of scary and the output is kind of ugly, in my opinion. So we built this tool. It stores data into MongoDB and lets you generate graphs, so you can look at what functions are taking the most time, what functions are allocating the most memory. And you can generate call graphs that allow you to see, critical path type things. So you can see, well, we go through and then we end up at a view, and the view takes the most time. So then from there, you can zoom in on the view and then figure out what's going on inside there, because this is an inclusive time, so each ball, the size of each parent will be a little bit bigger than the one the ball of each parent will be larger. You can also do exclusive or self times, where you'll see specific balls being very large because they're taking a specific amount of time. Xdebug is not suitable for servers with traffic. It gives you very, very detailed results, though. It will give you detailed results on every function call and every, just really, really low-level results that are very useful. You can take it'll output a file called a cache grind file, and you can put that into another tool like WinCache or kcache grind or WebGrind. And WebGrind will let you look at the results and see what the invocation costs, how many times a function was called, how much time it took itself, how much time it took for it and all of its all of the functions it called. And so what I usually end up looking for in here is functions that get called too many times. That's a quick way to solve a problem. If you have a loop and it's maybe running twice and you're like, well, I should only be calling find 4 times, and you look and it's like find is being called 50 times, then why? So then you click on find, you see what's calling find, and then you see, oh, there's this, it's getting called 25 times from this other function. That's weird. Go look at the code. It's getting called because the loop is getting run twice, or the boundary conditions are wrong. Or maybe you're calling stir pause 55 million times. These kinds of things happened. Yeah, you want to look for functions with high self-cost and high invocation counts. Again, you're looking at, if you're trying to get 10% savings, saving 10% of one method call, not much to save there, right? You got 399 microseconds, so 5%'s 20 microseconds, not even. Yeah, so you want to go for 27,000 microseconds. You can shave 2,000 microseconds off that. That's 2 milliseconds. Other PHP tweaks, if you don't have opcode caching, don't look at your code. The first thing you should do is put opcode caching in. You'll get double to, basically double performance by having an opcode cache. If you're not running APC, or if you're on 5.5 and you're not running opcache, the OP cache, just turn them on. I'm surprised that you're still running. FreshBooks, for example, if you turn APC off, we go down. Because we don't have that many servers. So we don't do that. Don't use file-based sessions is another thing. File-based sessions have very interesting locking semantics. By interesting, I mean annoying. What they will do is only one process can ever open a session at a time. So if you have a really AJAX-heavy application and you're wondering why all your requests are lining up in a row, it's probably because of session locks. So switch to something like Redis or to APC-based sessions, and then or database sessions, and that will go away. This also means that you have concurrency problems. The reason file-based sessions lock is to avoid concurrency issues. So try and write to the session as seldom as possible, or don't write to the session when you know there's going to be a lot of concurrent actions going on. So those are the two things. Yeah, I talked about that. Yeah. So in closing, make sure you measure everything. If you're going to change something, measure it, change it, and then measure it again. If you fail the first or the last step, you just should not ever do the middle step. Yeah, if you're going to change it, measure it. Otherwise, you won't know what you're doing. Start at the cheapest things. Start with the things that will take the least amount of effort and get you the most amount of gain. Profiling code is often a very laborious process. Adding in gzip takes 2 seconds. So if you don't have gzip, it's 2 seconds to add a line, restart Apache or restart Nginx, and you've got huge savings. So yeah, start with the cheapest things. Start with the things that have the most impact for your business or the most impact for your customers. I would recommend starting in the front. You can save a lot of you can get a much bigger gain by attacking the front end versus attacking the back end. If you can avoid work, do it. Defer any work you don't have to do. Use queues, use delayed jobs, use cron jobs, use anything to make sure to take work out of your request process and put it into a back-end process. Optimize your code. Once you're done everything else, start attacking your SQL queries and your database, your SQL queries, your cache hits, and your code. And that's pretty much all I have. I have 15 seconds left for questions. 2 seconds for questions. 0 seconds. If you, yep. The explain, it's PT Visual Explain. It comes with the Percona tools. So there's a bunch of tools. There's a bunch that I've never used, but I use PT Visual Explain all the time. The other one is PT Query Digest, which is the one you can feed slow query logs into and get the histograms of what queries are running and which ones are slow. So those are useful. Yep.
Do you have any tools for profiling from a browser, but not your browser, if your users are somewhere else, like different geographical areas, etc., you want to see how they see the site?
I don't have any tools. The best tool I would probably guess is if you've never heard of a service called New Relic, it'll track slow requests, and if they're really slow, they'll show up in New Relic as a slow query. That's probably your best guess. Another option is to, if you're using XHGUI or XHprof, you can selectively enable XHprof based on, you can selectively enable XHGUI based on a callback, so you can do stuff like whitelist their IP or take their session cookie and whitelist it, and then you can get profile results that way. Yep.
You didn't plug your asset compress.
I didn't, no. But yeah, you can use that. Also gulp, like the JavaScript-based tools, or asset compress is another plugin I wrote for doing asset minification in CakePHP. Yeah. Okay. If you have more questions, I'll be around. You can grab me anytime. Thanks.